Welcome to Summarize Science. Today we are exploring a major breakthrough in how AI understands and interacts with our physical world. Imagine asking a computer to set a dinner table just by typing a single sentence instruction. While modern AI models are amazing at understanding language, they have historically struggled with 3D spatial reasoning. In the past, AI-generated scenes often featured spoons floating in midair or plates merging directly into the wood of the table. To fix these immersion-breaking errors, researchers developed a new system called Stable. This system uses a dual-system approach that mimics how a human might think about a task and then double-check the physical results. The first part of the system is the semantic reasoner, which interprets the text instruction to create a rough, initial layout. This brain of the system decides which items are necessary, like a teapot or a cup, and where they should generally be placed. Then, the second part, called the physics corrector, takes over to refine the scene and fix any mistakes. The physics corrector acts as a specialized filter that calculates the exact geometry of every 3D object in the scene. It uses advanced math to ensure every item is resting solidly on a surface and that no two objects are occupying the same space. The team designed the system to work progressively, building the scene in 3 distinct stages. It starts with the most important objects for the task, then adds background items, and finally fills in the smaller details. This step-by-step method prevents small errors from piling up and ruining the physical realism of the entire setup. In their tests, Stable outperformed several other AI models by virtually eliminating collisions and floating artifacts. They also measured how well the scenes matched the original human instructions, and Stable came out on top there as well. Look at these side-by-side comparisons where other models leave objects missing or misaligned while Stable gets them right. One of the most interesting findings is how well the system generalizes to new and unexpected situations. It can create realistic layouts on types of furniture it hasn't seen during training, such as nightstands and TV stands. The AI even knows how to handle complex physical relationships, like stacking multiple books or putting small items inside of bowls. This level of detail is crucial for training robots to perform real-world chores or help out in a messy human kitchen. If a robot is only trained in a simulation that ignores the rules of physics, it won't be able to function effectively in a real house. By making these virtual simulations ready for reality, the researchers are paving the way for smarter, more capable home robots. To recap the important points, Stable successfully combines a creative language brain with a strict physics body. It uses a 3-stage process to build tabletop scenes that are both logical to humans and physically possible for robots. This overcomes the major limitations of previous AI models that were purely focused on text and lacked 3D awareness. In the future, this technology could be used to automatically generate entire virtual worlds for training, research, and even gaming. It marks a significant step toward AI that doesn't just talk about our world, but truly understands the rules we live by. Thank you for watching Summarize Science, and stay tuned for more breakthroughs in technology.